These are the notes for Algebra 2, Section 3.1, pages 153 to 155 in your textbook. They have to deal with solving systems of equations using graphing. Now, to start with, a solution to a system of equations, a system of two linear equations, that is an ordered pair xy that satisfies both equations. Now, to break that down a little bit, a system of two linear equations is essentially if I have two equations that are related. And I can find the solution by finding the point on the graph of both of those lines where they intersect. So, here in this example, I have equation 1 and equation 2. Equation 1 I've graphed in green. Equation 2 I've graphed in blue. And as we can see, these two lines intersect at the point 2, 0. So that is the solution to this system of two linear equations. That means that to find the solution to two linear equations, we can graph both of the lines and see where they intersect. So let's give that a shot. For each one of the equations that I'm going to graph in this video, I will always be solving for y. That's the method that I'm going to use. I could, if I chose, find the x-intercept and the y-intercept, but today I feel like it would be better if we just solve for y. So, let's start. The first equation here, I have y equals 3 over 2x plus 2. Fortunately for us, this has already been solved for y, and it tells us if y equals mx plus b, then m is 3 over 2 and b is 2. So let's go ahead and graph this line. That means we start at b, the point where it crosses the y-axis, and put a point. Our slope, m, is 3 over 2, so I will rise 3 and run 2. Now, as you can see, that would take me off of the graph a little bit, so I can do the equivalent move, which would be to move downwards 3 and backwards 2, and put a point. Now, we can see that if I had estimated a point up here, it would still create a straight positive line. I can do this one more time, this downward 3 and backwards 2 movement, and that is enough information to plot my line. So I'm going to go ahead and do that. The second equation, x plus 2y equals negative 4, I do have to solve for y. Y is not by itself yet, so I'm going to do that. The first step will be to subtract x. Now, when I subtract x, it will cancel out on the left side, and I will have 2y. On the right, negative 4 and negative x do not combine. They do not have the same variable. So the only thing I can do is write negative x minus 4. I'm still trying to get y by itself, so I will divide both sides by 2. And when I divide by 2, I have to divide everything by 2. On the left, I'll cancel out, and I'll have y. On the right, I will have negative 1/2 x, because negative 1 divided by 2 is negative 1/2, minus 2. That means that my m is negative 1/2, and my b is 2. So I'm going to plot some points and draw my line. My b is negative 2, I'm sorry. So we go down to negative 2 and plot our point on the y-axis. Then we follow the slope of negative 1 over 2. That's a negative slope, so it should be pointing downwards. I move downwards 1 and forward 2, and I get some points. Now I can graph my line because I have enough points to do that. Graph my line. And there it is. Well, now I can see that my solution is right here. It is the point negative 2 negative 1. So that's my solution, negative 2, negative 1. I'm done. Alright, I would like you to solve this system of equations by graphing. You're going to need to solve both equations for y. Then plot the points and see where they intersect. Pause the video, find the solution, and then unpause the video and see how you did. Okay, we can see here that I solved the first equation in purple and I graphed it in purple. I solved the second equation in blue and graphed it in blue. I solved both equations for y. I ended up with, for purple, y equals 1/2 x minus 2. And I graphed that line. In blue, I graphed y equals negative 1/2 x plus 2. And I graphed that line in blue. You can see the negative 1/2 x line is pointing downwards, the positive 1/2 line is pointing upwards, and they intersect at the point 4, 0. So that is my solution. Now, when we're dealing with systems of equations, there's a little bit of vocabulary that we use. We need some words to describe the 3 different possible types of systems with 2 variables. Anytime we're graphing or solving 2 systems of linear, 2 equations in a linear system, there are 3 possible types of answers. One is if I have 2 lines that are just regular old plain lines, they intersect at a single point. They have exactly one solution. They are considered consistent and independent. Consistent means that there is at least one solution, and independent means that each line contains different information about the variables. We could have 2 lines that when I graph them sit directly on top of each other. And so in our second example here we can see that there's only one line graphed. That's because the second line that we would have graphed is sitting directly on top of the previous line. What that means is that the 2 lines coincide, and if they coincide, they're intersecting at every single point. And since the solution to a system of equations is where the lines intersect, there are infinitely many solutions. Since there's more than at least one solution, it is consistent. But since both lines are the same, they are dependent. The third possible situation is that there is no solution. We get no solution if the 2 lines that we graph are parallel. Since parallel lines will never intersect, there is no solution. Since there is not at least one solution, the system is considered inconsistent because there's no solution. If the system is inconsistent, we don't worry about independent and dependent. So one of the things we're going to need to be able to do is decide if a system is consistent and independent, consistent and dependent, or inconsistent. For example, I want to decide if this system is consistent and independent, consistent and dependent, or inconsistent, and tell what the solution would be. So, we don't need to solve the second equation for y because it's already been solved for y. What I'm going to do instead is just go ahead and plot my point and draw my line. It's the easier one. I always want to do the easiest ones first. So b is 4, so I'm going to go up to 4, 1, 2, 3, 4, and pop a point down. My slope is 2 over 1. That means I need to rise 2 and run 1. Since that would take me off of the graph, I'm going to do the equivalent move of down 2 and backwards 1. It's the equivalent move. If I had put a point there, it would still work. Now, I can do that a couple of times and graph that line. And there we have it. Now, the first equation I do need to solve. So I'm going to go ahead and do that. Negative 2x plus y equals 4. I want to solve for y. So I will start by adding 2x to get y by itself. When I do it on the left, I have to do it on the right. Just like before, 2x and 4 do not combine because they do not share the same variable. So the only thing I can do is y equals 2x plus 4. Well, now, the second equation was also y equals 2x plus 4. That means that I would have a b of 4 and an m of 2. So again, I would plot a point at 4, do the move of downward 1 and backwards 1, and I would end up with a line sitting exactly on top of the old line. Okay. And I'm going to change the transparency so we can see that maybe. Nope, guess not. That doesn't actually work. That's too bad. Anyway, we'll ignore that. The two lines are sitting directly on top of each other, whether we can see it or not. And we can tell then that there are infinitely many solutions. Since there are infinitely many solutions, that means that this system of equations is consistent and dependent. So I'm going to put that down too. Consistent because there is at least one answer. In fact, there are infinitely many. And dependent because both of the lines are the same. So the two parts to our question have been answered. It is infinitely many solutions, consistent, and dependent. All right, let's try this one. Now this one I do have to solve both equations for y. I'll start with the first one, negative 2x plus 4y equals 8. I have to add 2x to both sides. I get 4y equals 2x plus 8. So I divide by 4. And I divide everything by 4. When I do that, I get y equals 2 divided by 4 is 1/2. So 1/2 x. 8 divided by 4 is 2. So I get 1/2 x plus 2. I'm going to go ahead and plot these points. My b is 2. My m is 1/2. So I'm going to go to 2. And rise 1, run 2. And here's the line that I get. Go ahead and plot that now. And there it is. I need to solve the second equation, which is negative 2x plus 4y equals negative 4. Have to solve it for y. So I add 2x to both sides. On the left they cancel out, and I have 4y. On the right, 2x minus 4. Same exact move here. I'm going to divide by 4, divide by 4, divide by 4. Y equals 2 over 4, 1/2, x minus 1. Negative 4 divided by 4 is negative 1. That means b is negative 1, m is 1/2. So I start at the y-intercept of negative 1, rise 1, run 2, rise 1, run 2. Plot a few more points, and draw my line. Oops, that's the wrong color. Let's try that again with a color that would probably work better. Let's try that with blue. How about blue? There we go. Oh, that's much nicer. As we can see, these two lines are parallel. That means they're never going to intersect. If they're never going to intersect, there is no solution. None. The solution is where they intersect. They do not intersect. There is no solution. If there is no solution, these two lines, or this system of equations, is inconsistent because it has less than one solution, and in fact has no solutions. We don't decide whether it's independent or dependent because it is inconsistent. All right. Pause the video, graph these two lines, find the solution, and then tell me whether or not they are consistent and independent, consistent and dependent, or inconsistent. Pause the video, find the solution, answer the question, and then unpause the video and we can see how you did. All right, here we go. I solved the first equation in blue, and I got y equals 3 over 2x plus 3, which I plotted in blue. You can see my y-intercept was off the grid, but that's okay. I still managed to get it done. In purple, I did the second equation, and I got y equals 5 over 4x plus 2. Plotted this one in purple, and I can see my two lines intersect at the point -4, -3. It's where the two lines cross. That is the solution. Since there is exactly one solution, this system of equations is consistent and independent.